All right, Unit 5, Progress Check, Part B. We're going to look at 7 through 9. So, number 7, let f be the function defined by f of x equals x to the fifth minus 10x cubed. The graph of f prime is shown above. On which of the following intervals is the graph of f concave up? So this is similar to question 6. So I have this part here in orange. It says if the derivative is increasing, then f is concave up. If the derivative is decreasing, then f is concave down. So we want concave up. So we want when f prime is increasing. So increasing from this point up to 0, and increasing from this point up to, it must keep going there. So concave up are those values. Well, what are those values? We could do the math and figure it out, although what we can do here is we can look. That's at negative 1 point something. That's at 1 point something. Well, the only numbers we deal with here are root 3 and root 6. So square root of 3 is 1 point something. I think it's about 1.7, but you at least know it's 1.7 because the square root of 4 is 2. The square root of 9 is 3, so the square root of 6 is 2 point something. So these are both at 1 point something, so it has to do with the square root of 3. So it's concave up when x is between negative root 3 and 0. And so it looks like negative root 3, and 0, and then x is greater than root 3. So our answer there is B. Number 8, the second derivative cannot be used to conclude that x equals 2 is a location of a relative minimum or relative maximum for which of the following functions? So second derivative test still uses the first derivative because you want to find when the first derivative is 0 and then use the second derivative test. And if the second derivative is positive, then it's concave up. Concave up means there's a minimum. If the second derivative is negative, it's concave down, which means there's a maximum. And if the second derivative is 0, you can't use the second derivative test. So no conclusion from that, from the second derivative test. So really, we need to make sure the first derivative equals 0, and then we need to see the ones that won't work. You can't use the second derivative test if the second derivative is 0. So let's first make sure we plug in 2 and the first derivatives are 0. So first derivative, plug in 2 there, in there. Sine of 0 is 0, so that's 0. Putting 2 in here, this would be a 2 and a 2 and a 2. So this is e to the negative 1 minus 1/2 times 2 that cancels, and then this would be minus e to the negative 1, so that's 0. Putting a 2 in here is really easy, that's 0. Putting a 2 in here, that's 2 squared is 4 times 3 is 12, minus 24 plus 12 is 0. So first derivative all equals 0, so they all check out. So now we have to look at the second derivative. Second derivative, we kind of have to, we're going to go through and see which one doesn't work. I would probably start with the ones that are easier first. So C, that's nice and easy. So for C, the second derivative is 2. And again, we're looking for, it won't work if the second derivative is 0. So second derivative works for C, so it's not C. D is another easy one to do. Second derivative is 6x minus 12. Plugging in 2 gives us 12 minus 12, which is 0. And that's when it doesn't work. So it doesn't work for D. So the answer is D. So again, doing the ones that are simpler first, we could have gone straight through, done A, B, C, and D. So if we tried A, the derivative of sine, well, the derivative of negative sine is negative cosine of x minus 2. And if we plugged in 2, we would get negative cosine of 0, which is negative 1. So that would have worked. B, we could find the first derivative. That's the one I would have avoided as much as I could. If I would have gone through and found that A, C, and D all work, I would have just assumed B doesn't work. So sometimes you can, which we didn't have to here, we found that D doesn't, the second derivative is 0. All right, number 9. The second derivative of a continuous function f is shown above on the interval 0 to 9. On this interval, f has only one critical number, which occurs at x equals 6, which the following statements is true about the function on 0 to 9. So it only has one critical number at x equals 6. This is the second derivative. So when the second derivative is positive, it's concave up. F is concave up, I should say, which means if it's concave up, there's a minimum at the number. So at 6, there's a minimum. So is it A? Is it B? These two talk about maximum, so it's not C or D. So is it a relative minimum or is it an absolute minimum? Well, since x equals 6 is the only critical point, it only has one critical point on the interval 0 to 9, and so therefore it has to be an absolute minimum because it's the only one on that interval. So the answer is B.